Good morning, class. For today's lecture, I will be cover on Anova analysis of variance. Okay, basically, this is the content that we will cover in this lecture, chapter analysis of variance. First one is one-way analysis of variance. Second is Chefe test and two-key test, and then the third one will be two-way analysis of variance. So there will be three parts. So I just divided into three different videos. So you guys can refer part 1, part 2, and part 3. Okay, let's begin with part 1. Part 1 is one way of Anova. So as an introduction, the F-test is used to compare two variances. Can also be used to compare three or more means. Okay, so you guys can see here. So we used to compare three or more means. So this technique is called analysis of variance or Anova. For three groups, the F-test can only show whether or not a difference exists among the three means, not where the difference lies. Okay, they just want to identify, they just want to show that is there any difference or not. They don't want to identify what is the particular differences. Okay, so other statistical tests like Chefe test and two-key tests are used to find where the difference exists. Okay, you see two different things. F test, they identify is there any difference exist or not. But Chefe test and two-key test, they will identify where is the difference. Okay, one way of analysis of variance when an F-test is used to test a hypothesis concerning the means of three or more populations. The technique is called analysis of variance, commonly abbreviated as Anova. Okay, so the one-way analysis of variance test is used to test the equality of three or more means using sample variances. Okay, you have to remember they always try to compare more than three, more or equal to three means. Assumptions. Okay, these are the assumptions that we will consider. This will be an Anova one-way test. Okay, for example, the population from which the samples were obtained must be normally or approximately normally distributed. There should be a normal distribution in general. Number 2, the samples must be independent of each other. Okay, they must be each other's independent sample, which means they separate from. Okay, they have three groups, means all the three groups, they have their own samples. The variances of population must be equal. Okay, and then F test. In the F test, two different estimates of population's variance are made. Okay, the first estimate is called between group variance. Okay, between, just remember, between group variance, and it involves finding the variance of the mean. The second estimate, they say two different estimates, right? Okay, the first one is this and the second one is here. The second one is within the group of variance, is made by computing the variance using all the data and is not affected by the differences in the mean. Okay, let's look at an example. Example number 1. A researcher wishes to try three different techniques to lower the blood pressure of an individual diagnosed with high blood pressure. The subjects are randomly assigned to three groups. Okay, they already mentioned three groups. Obviously, it's going to be one way of Anova. And the first group takes medication. Second group takes, go for exercises. And third group follows a special diet. So this one is in order to lowering the blood pressure. Okay, they go for medication, exercise, and diet. After 4 weeks, the reduction in a person's blood pressure is recorded at alpha 0.05. The test the claim that there is no difference among the mean. Okay, and the data are shown below here. So we have like 1, 2, 3, 4, 5 records. For each they have the 5 records lah. Okay, and they already come out with, okay, when you got 3 different groups, what you have to do is you have to come out with the mean and standard deviation, variance. Okay, mean and variance of that particular group. So here for the medication, the mean is 11.8, for exercise 3.8, and diet is 7.6, while the variance is for medication is 5.7, exercise is 10.2, and diet is 10.3. Okay, remember class, definitely we will be utilizing this information, okay, later on when we do the testing part. Okay, as a solution you have to start with 5 steps. Okay, step number 1, identify the hypothesis. Step number 2, critical value. Step number 3, the test value. Step number 4, your decision. Step number 5, summary. Similar things that when the things that we have come across during hypothesis testing. Okay, the steps are similar. Only thing is the formula and application is slightly different. Okay, let's go with the first step, hypothesis. When you have a hypothesis saying that your claim, in this case your claim, see here, test the claim that there is no difference among the means. So we want to test all the means are equal. Okay, all the means are equal. So we have 3 different groups, so 3 different means. So we want to claim that all the means are equal. That is your H0. So your H1 will be at least one mean is different from the others. One mean is different from the others. So which means the means are not equal for all the 3 different classes. As for the second step, find the critical value. Okay, since k equal to 3 and n equal to 15, what is k? K is actually group 1, 2, 3. So total how many groups? We have 3 groups. That is what they mentioned. K equal to 3, n equal to 15. The data, okay, the data is 5. Okay, 5 plus 5 plus 5. We have n is equal to 15. So in this case, we have degree of freedoms numerator, we have k minus 1. 3 minus 1 is equal to 2. And on the denominator part, we have n minus k, which is 15 minus 3 equal to 12. So this critical value we can identify from table H. In exam, they won't give as a table H. Instead, they will let you know that it's a F distribution table. Remember this, F distribution table, because it's a F test. Okay, with the alpha of 0.05. Okay, let's see. So you have to check for the alpha, okay, from the table that given. You check on the alpha value. After that, check on DFD. Okay, and then check for your DFN. Okay, sorry, this will be your DFN and this will be your DFD. Okay, so 12, 2, so the value will be somewhere here. Okay, so the value that we obtained from the table is 3.89. Okay, we are done with the critical value. So usually we will compare the critical value with the test value. Okay, now we're going to compute the test value. Okay, for the in order to compute the test value, we have few steps that we have to follow up. Okay, first step, here in this case 3a, find the mean and variance of sample. So for each samples they already mentioned their variance and mean, so you don't have to do, you don't have to calculate that. Second step, find the grand mean. Grand means is denoted by x bar gm. Okay, gm is stand for grand mean, x bar is the mean, is the mean of all values in the sample. So which means you total up all the values, you total up all these values, all these values, all these values, add together, get the sum, divide by 15, so that you will get 7.73. When the samples are equal in size, find xgm by summing the x, okay, the means, and dividing by k, where k is equal to number of groups. So we will see that. Okay, this is a formula. Total up all the x, okay, divide by total number of n, so you will get the value of xgm, x bar gm. Next, see here, find between. Okay, we have come across two things, right, just now, between group and within group. So we will calculate these two estimates as well. Okay, how to calculate? There is a formula. So this is the formula which is denoted by B, variance denoted by B. B is between group variance. Okay, 5. Okay, this 5 is actually for group number 1, group number 2, group number 3. Okay, so 5 in bracket 11.8. Okay, you can see this 11.8 is come from here, and the variance is 5.7. We didn't use the variance because we want to calculate the variance between the groups. So 5 times 11.8 minus 7.73 square plus 5 times 3.8. So the 3.8 is given in the table just now, minus 7.73 square plus 5 times 7.6 minus 7.73 square, divide by 3 minus 1. K minus 1 means 3 minus 1, which is divided by 2. So you will get 80.07. This formula finds the variance among the means by using the sample sizes as weights and considers the differences in the means. Next, D, find the within group variance denoted by S square W. Okay, S square W, you can see here. Let me change the color. Okay, so the formula for this one will be sum of n minus 1 times weight variance divide by sum of n minus 1. So 5 minus 1, okay, n minus 1, and then times with 5.7. 5.7 we already got here. Okay, this variance will be used in the calculation now. Okay, 5 minus 1 times 5.7 plus 5 minus 1 times with 10.2 plus 5 minus 1 times 10.3 divide by 5 minus 1 plus 5 minus 1 plus 5 minus 1, which means 3 times 4, which is 12. So you got 12, total up this, and you will get the value within group. Okay, within group is 8.73. So this formula finds the overall variance. Now we already got the two variants. What you have to do is, for the F test, there's a division of the bigger value divided by the smaller value, which is between divided by within. So 80 divided by 80.07 divided by 8.73 is equal to 9.17. So now you can make a decision, test value compare with, okay, versus C value, critical value. Okay, so as your test value is greater than the critical value, the decision is reject the null hypothesis. Okay, and your summary is there is enough evidence to reject the claim and conclude that at least one mean is different from the others. Or in the other way, you can say that there is not enough evidence to there is enough evidence to accept the H naught. Okay, very simple. Okay, to accept, okay, for this case, accept H1. In this case, reject. Okay, reject H naught. Accept and reject. So this is the summary. It's quite easy, so I hope you guys can catch up with this. Okay, we'll continue. Anova. The between group variance is sometimes called mean square, MSB, and the numerator of the formula is to compute MSB is called sum squared between groups. Actually, there is a Anova summary tables that you have to do in your exam. Okay, I'm sure that your final exam got this type of question where you need to use the table to fill up these values. Okay, this value you already calculated before, so you just fill up in the table. So the within group variance will be, okay, between will be B, within will be MSW, and the numerator of the formula to compute MSW is called the sum square within the group, so SSW. So SSB and SSW here. Okay, let's see. Okay, this is things that you need to fill up. Sum square, degree of freedom, mean square, and also the F-test value. So for the example number 1, just now, the values are between. Okay, we already calculate between, right? So what is the value of between? So between is 160.13. Okay, so 160.13, that is the sum of this, and then next will be your within, which is 104. Okay, because it's just a sum square, they are not division. Okay, the value that we notice here is actually mean. Okay, it's actually it's actually calculating the variance. But in this example, if you notice, okay, they want to identify some squares. Okay, sum of the square of x value and the x bar value. So in this case, for the between, we have 160.13, within we have 104.8. So total is, you just total up all these, you'll get 264.93. Degree of freedom, the first one is 2, second one is 12, so total is 14. So the mean square value will be 80.07 for between, and within you got 8.73. So the F value will be 9. Okay, this one is the test value. Okay, test value is 9.17. Can you see this? 9.17. So in exam, actually there is a question something like this that you need to fill up. So for this case, you just need to fill up the values, but you don't have to show the whole calculations. So simply you can use your calculator. If you still want to show the slides, if you still want to show the value, so you can check back the the steps. Okay, if you want to show the steps also, no problem, but marks only given for this particular table. Okay, example number 2 now. A state employee wishes to see if there is a significant difference in the number of employees at the interchanges of 3 states. Okay, 1, 2, 3. The data are shown at alpha 0.05. Can it be concluded that there is a significant difference in the average number of employees at each interchange? Okay, actually, in order to identify which one is the claim, okay, remember, not all the time H0 will be the claim. Not all the time H1 will be the claim. There's vice versa. There's possibility that either H0 can be claimed, H1 can be claimed. Okay, so mean for Pennsylvania is given, mean for Greensburg given, mean for Valley is also given, variance also is given for each of these groups. So let's come out with the hypothesis. The first hypothesis is H0 mu1 equal to mu2 equal to mu3, because since there is no equal in the paragraph, okay, is there any significant difference between the average number of employees? So we don't have any equal sign over here, so that the claim automatically will go for H1, alternative hypothesis. So at least one mean is different from the others, so this will be your claim. So you want to justify, is there any mean is different from the other mean, one group of mean different from the other. Okay, so second step, the critical value will be k equal to 3, n equal to 18, alpha 0.05. So you basically get the value, okay, dfn and dfd, and the critical value from the table. So table H, yes, now table H, right? Yes, table H. So, or you can simply find F distribution table. So we already got the critical value 3.68. Now we want to identify step number 3, calculate the mean and variance. It's already done in the question, I mean the description of the issue. Find the grand mean. Grand means is total up all the values, total up all these values, total up all these, divide by 15, 16. Okay, is it 16? No, 6, 6, 12, 12 plus 6 is 18, sorry, 18. So you got the grand mean, GM is 8.4. Now we want to identify the variance between the group, which is sum of, okay, x, sum of n, which is 6 times 15.5 minus 8.4 plus 6 times with 4 minus 8.4, and then 6 plus 6 times 5.8 minus 8.4 square. So when you do this, you will get 22959 within the group. So apply the formula, n minus 1 is 6 times 81.9. This 81.9 we already calculated previously, so you don't have to refer here. This one is already given. If let's say in your exam they didn't give, what you can do is you can try to do yourself. Okay, next, within the group we got 6 minus 1 times with the variance, 6 minus 1 times with the variance, 6 minus 1 times with the variance. You get 3 different samples here. Okay, 5 times plus 5 times pi plus 5 plus 5 will get 15. So your within group variance is 45.5. Now we need to divide DFD, okay, sorry, between divide by within, which is highest, divide by the lowest. 229.59 divided by 45.5, you will get 5.05. So this case I think slightly different from the previous one. So now we will go on with the before summarize the result, we have to make a decision. So in this case 5.05 is greater than 3.68, so reject null hypothesis, and then summarize the result. There's enough evidence to support the claim, which means accept the H1, accept H1, okay, reject H0. So the value between within, so total degree of freedom is 2, 15 and 17, and the last one mean square we get 229.59, and then for within is 45.5. These values, so the variance, so we just collect from there. And the F value is test value, which is 0.5, sorry, 5.05. Okay, so this is the part 1. We'll continue with part 2 after this. Thank you, class.